So this is the pit that the dyno is going to go into. Hopefully after a couple of days you'll see a dynamometer in there. I was a bit concerned about the drain hole being where the rear roll set might set, but I think the width back here is ample enough that the rear roll set can sit in this area without having any issues. What's going to happen is the rails are going to go across that hole, but I don't think that's going to be a big deal. We should be fine. They've got conduit over there, and it looks like the conduit is intended to come up out of this piece here, and they're going to set the computer on this platform over here underneath the window. Sensor box, not sure where we're going to want to put that. Might be better to have a wall mount type sensor box rather than a trolley. Okay, we're at Kirkwood Community College, and we're here to help install this 8030 all-wheel drive. We've unbanded 3 of the pallets. You can see one has long rails on it. This one over here has some support brackets. This box, the crate, appears to have computer and a number of other things in it. We haven't unboxed it yet. We have all these panels that are going to be part of the covers that go in the over the pit. So those are all on that pallet. So we've got a pretty interesting jigsaw puzzle here. We're going to try to lay out a lot of the pieces to see if we can get an understanding of how it all goes together. We'll do that here this evening. So over here we have another pallet with more panels on it. Those will be part of the covers that go over the front of the dyno in the pit. Again, we'll have to lay them out so that we understand the actual layout of this thing, so that it'll make it easier to do the installation. Alright, so we unpacked everything, and we have some of the frame supports laid out here. These pieces back here will bolt to the rear roll set, and then this will be a cross member that supports the platforms between the 2 roll sets. This will be a lower cross member that bolts up to these pieces. I think we got these pieces turned around backwards. The 2 bolts you see in the middle will be used for the eddy current. That black stand over there, we'll go over there and see that in a minute. And then this cross rail goes into the front. We do have these laid properly because that end will be bolted into the front of the cement rail or cement wall. And then these are just cover plates for the very front. We have the sensor box over here and the trolley for the sensor box. I laid out anchor bolts. These are going to be wedges for the rear roll set to wedge it into the pit. These will be the anchor bolts for those front panels that we just looked at. All these bolts, I'm not sure what they go to. We'll figure it out as we go. I think these are all cover bolts. Not sure what all this paraphernalia is for. We'll figure it out as we go. Same with all the washers. And then I think those 2 feet are going to go on the eddy current. Okay, we have the cow weights, 5 20-pounders, the calibration arm, and I don't see the bolts for the calibration arm. So those are missing. They were missing on the last system that I installed. Well, not installed, but was associated with. This will be the platform that'll support the front of the, or this bearing of the drive shaft. So some of those anchor bolts that we saw over there will be going into the floor to hold that into the floor. It'll be on this 4-pit pole here. We have the computer. This airline and this cable are going to go between the 2 roll sets. Ethernet cable for the computer to the sensor box. a variety of other cables that are used once the system's put together. Umbilical cable is going to run from the rear roll set interconnect box to the sensor box. And then we have a handheld over here, and a variety of cables that are part of the computer system, the printer, and the sensors for the data acquisition system. Okay, this pallet has the panels that will be the top sliding panels on the front area in front of the front roll set, and then between the rear roll set and the front roll set. Notice how some of these have a bent over section. The top two have that, and then the others do not. Okay, so those with the bent over sections, those are center panels. They go in the center, and that's so you can lift them out to have access into your pit. The others, the rail or the sharp edges will just go down on sliders that you'll see over on the other panels. Okay, these are the these would be what we would call the fixed pieces. They have the nylon strips on them, which those edges that you saw over there on those other panels will glide across that. Now these panels all have these square holes in them, and the original concept was there would be rollers where those square holes are, but that design got changed and they used the sliders instead, so there are no rollers. The square holes are unnecessary and not used. Okay, so we kind of laid out the rails, the way they're going to go into the pit. This cross member here will go between these two long rails. The long rails will bolt to these short pieces. You can see it over there. And then the back part will bolt to the dyno. So once we get the rear roll set into the pit and get it to the right height, then we build out the rails. There's the front pieces that will go against the front wall. It all has to fit. Hopefully the pit is slightly longer than necessary, because we'll use some adjustment of the rear roll set to move it forward to take up any space. If the pit's too short, then we got some issues. We thought maybe dropping the front roll in first, pushing it up out of our way while we build up the rear roll and these frame rails would be the right idea, but because I have to put the uprights into the front to make sure that we have the total length proper, we may not be able to do that. It's going to be a tricky setup to see what we got to do to get the correct length. So depth is important, length is important. Width obviously is important, but yeah, the pit has to basically be almost perfect. And we'll find out how close it is when we get to putting this thing together tomorrow. Okay, so we put the wedges in here, and they send more than we need. We had 2 extras, so we've got one in this corner, we got one in this corner, one here in the middle, and then we got 2 over here in this corner. There's no position for anything here. And we have straps around the middle of this thing. And he's got a great big forklift out here. And what we're going to do is we're going to set the back roll into the pit, and then we'll build out the rails and the frame, and then we'll be able to lift the front roll over the back roll and set it down onto the rails. So that's the plan at this point. So here you can see the 2 extra wedges or machine pads that they sent. Again, we used 1, 2, 3, 4, 5. And they send 7. So you can see on these 2 front pieces, we already have machine pads screwed into them. So I'm thinking that these extra large machine pads were actually for those, and somebody didn't realize that we already had them on the rails, and so they're sitting here as extras. All right, you can see how they've got a forklift that's lifting this thing. That whole unit weighs about 4,000 pounds, so you need to have a really large forklift. And what they're trying to do is set the rear piece down into the pit. And once we get that set, we'll start building it out. So again, a very, very large forklift is required, not your basic forklift you find in a warehouse. Just clearing the conduit. Hey. Is that gonna hit? So now we got a problem. The hinge for the lift is going to hit the conduit, which was my concern. So one of the other things is we're going to have to get some cables connected here, and we may end up wanting to connect those cables and the air hose before we set this thing completely in there. And then these wires inside here are going to have to be tied up much better, because they're going to hit the roll or they're going to be against this screw thing. So I'll do that later. Okay, so another tip is put on your air hose, put all these connectors on, your big umbilical cord. Make sure you put it on before you drop this thing into the pit. All right, so we actually have it sitting. I wouldn't take those off yet. Well, look how low you are. You're gonna have to come up an inch or more. Is that what your plan is? Okay. I mean, how are you gonna get to these feet back here?
The ones down there?
Yeah.
Set up for a long extension.
All right.
We can't get to the bottom. I mean, that's what.
All right, so you can see we're probably 2 inches too deep. We're gonna have to raise this thing up, so that means a lot of adjusting and trying to get it level, and so that the platform tops fit on the surface of the pit. Okay, so we're gonna have to adjust the machine pads, and some of the machine pads have hex tops, so you can actually go down through these holes and get a ratchet on them and try to adjust them from the top. But then some of the others they put in just have threads, so you can't adjust them from the top. You have to adjust them from the bottom. So my recommendation would be to put them all in with hex head tops, so that you could adjust them from the top instead of adjusting them from the bottom. Okay, so they're getting it leveled out, and one of the things, as we noted before, was that the front leveling pads did not have hex connections on the top, so they have to use a wrench underneath to get to them. The other thing about those is they're actually longer than the ones with the hexes on. So these ones back here in the rear that they've gotten down through the holes in here, those are actually shorter in length, so they don't get as much extension out of the machine pad as they can in the front. So it would be nice if all of them had the same amount of length, and that they were all the long ones like what you have in the front. Now notice the panel he's got laying here. Basically the dyno has to be flush with the floor when they're all done. So this base deal here has to be flush. Okay, so these pieces that go in the front, this piece and this piece down here, they are the same. There's no left or right to those. And the same way with these pieces that are going to go into the dyno, they are the same as well. There's no left or right. They just are made the same, and they bolt on to either side. So as you can see, they have the rear roll set into the pit and leveled out. The pit was actually fairly level, but the actual floor of this test cell slopes a little bit, so that created some leveling issues to try to get everything flush with the floor. So anyway, they're going to bolt these rails down, and there's a big sump pump that has to go into this hole, so we've got to wait for the plumber to get back to put that sump pump in there. Okay, so here's what we've run into. We have the rails in place, and then you see the support pieces up there. You see the angled pieces. There's one over there as well. Once they leveled out the rails, now with these pieces here in place, and they're all the way in, and this rear roll set is set in place, the pit is now too short, so those braces up there will not fit in and bolt to the cross piece. So we'd have to make them shorter, or we'd have to move this back. Well, moving this back now is a major thing to try to do. The pit dimension here was slightly longer than our drawing, so it should have all worked, but it doesn't. So what they're doing is the cross piece that goes across the two rails, they're slotting that so they can slide it back ever so slightly and then be able to bolt those lower braces in. That's how we're going to gain the ½ inch that we need. Now, another way to have gained that ½ inch would have been to not have these lock nuts on these machine pads. So in the future, what we'd recommend is that you put the machine pad in all the way to that nut, all the way up. That means the machine pad is what is actually against the wall back here. Then the lock nut can go on the inside and lock the stud. That's the way it needs to be done. That gains you a ½ inch. Moving the dyno back, that would give us enough room up here in the front with the dimensions in our drawing so that this would all fit. So this is our solution for the pit being too short because of those wedges in the back. He's out here trying to grind this 3/8 inch thick steel. It's just taken forever. And he's going to have to do that to both the holes down there and both the holes down here. Okay, so these cables here from the factory, these cables right here, I tied them all in up in here. They were just a big blob right here, which means they could have got into the roll. They would have got into this. So I've got that all tied back now to where it should have been from the factory. Okay, it appears that we finally ran out of grade 8 bolts and nuts for them. The cross piece that they're putting in requires 2 bolts on each side, and we've ran out of the grade 8s, which there's a whole bag of grade 5s. We don't know what they're for, but there's no nuts, so we're going to probably use those. I see down on the very bottom down here they've used lock nuts, and that one's also a lock nut. That one there, that one down there, and that one down there, and then those 2 up there are regular nuts. So whatever we've done on our count for bolts, nuts, washers, the grade 8 variety, we have miscounted the total amount that we need. Okay, so what we're doing is we're pre-assembling these panels so that we can see if everything fits, and it looks like we've got enough gap, hopefully, to get all all the top pieces in. So,
See, that chunk there fits in, that gives us our gas. So if we weld it up on the outside of that, we're just gonna have to weld it.
so another thing I want to point out is these holes here, which are really for an above ground installation, but with the rear roll set all the way back using those machine mounts, the extra ½ inch, if they were moved back, those holes would be covering up on top of this steel plate down here, and theoretically I suppose a guy could bolt it into that plate. But bottom line is that it looks a little odd with that little bit of a gap showing there, and that is because we couldn't move the rear roll set all the way back with the lock nuts on the machine pads on this side of the machine pad, instead of taking the lock nuts off and putting them on the inside. So just something to note in the future. Alright, so we removed all the panels that we had sitting there temporarily, and now they're going to try to put the front roll set in. I got to stop them. I got to tell them some things first, because those machine pads have to come off, I'm pretty sure. They can't be in there, because if they touch the ground, the dyno won't roll. So I'm going to talk to them about that before they do anything further. Alright, so we're removing all the pads because they're completely unnecessary, because the dyno is going to sit on those rolls. It's going to sit on the rails. So they're going to go ahead and take those out, and then we'll set the thing in on the rolls. So you can see where we got all the shims in place, and they're going to plan on welding all those. I'm not sure when they're going to do the welding, but looks like they've got them ground out. Alright, so we got it fairly You got a big pry bar? You're off on this side. You're way off. Gotta go back up. Up. Now over. You're not. Looks like we got the train on the tracks. Okay, so we're welding in all the shims so that they can't vibrate or slide out from underneath those rails. And we got all of our front pieces, and then these pieces are going to be anchored into the floor. And then your stationary covers, they bolt to these holes here. What you'll notice is you have two holes that are straight, and those are going to be what goes to the edge. And then you have 2 holes down here, so that's how you know which way those panels go on. Okay, we have all the shims welded in for all the rails, and they're mounting the drive shaft. The drive shaft's been attached to the eddy current. We have it attached to the front roll set. And the carrier bearing in the middle, we're gonna have to put the plate under the cross member, and then we'll shim the carrier bearing. The drive shaft, when you slide the front roll set in and out, that carrier bearing can't move up or down more than 1/8 of an inch. We checked ours, it doesn't move at all. So we should be in good shape. It's just we gotta figure out what to do to put underneath there so we don't put any kind of stress on that bearing. All right, it's close to the end of day 1. It's about 10 after 7. They've been here working since 8 o'clock this morning. And we've got pretty much all the frame done. We've got the rolls set in. We've got the drive shaft in place. We don't have electrical, and the plumbers still have to put their stuff down into that plumbing hole. They're trying to set all the feet on the rear roll set. There was some shims that they needed to put in. Still quite a bit of work to do tomorrow, because these front panels have to be anchored to the floor. These front frame pieces here and over here have to be anchored into the wall. We're thinking about just welding them into the metal piece. The rams have to be connected. So the electrical has to be put in, and then of course all the covers have to be put on the top. But with any luck, we'll get all that done tomorrow. And so 2 days, they had 2 guys working, figure 10 hours today, that's 20 man hours. My time, another 10 man hours, so that's 30 man hours. Then they had a guy here that was doing rigging and a couple other helpers, so let's figure another 10 man hours. So that's 40 man hours just in the first day. Tomorrow will be another day with probably another 40, so you're probably looking at about 80 man hours to do this job. Okay, so again, end of day 1. It's now about 7:30. We got the rams put on, but they're not secure. So those will have to be done after we get the electricity so we can actually extend them. The plumbers have to put these 2 sump pumps in, and this pipe that's sticking out right there is where they're going to put the drain. So somehow or another they're going to plumb into that. It's going to be a tight deal, I think. Whoever came up with that idea didn't do a very good job with it. Electrician will be in the morning to run the wire from over there into the junction box and to hook up this ground. But they made quite a bit of progress in the first day, more than I would have expected. All right, so you can see in this cross member here that they slotted these holes on the bottom. That gives this cross member some adjustment fore and aft. That's so that that rail up there, you can get it to fit, because it has to get in here and it has to be against that wall. And if we were back too far, that doesn't hurt anything. We'll just shim it. But if we're too close and we can't back this up, then we've got a problem, because the pit's too short and this won't fit. So having some slots down here would make perfect sense. Now, as far as this cross member, this piece is for, let's come over here. So this should be sitting, try to get in here. So this should be sitting on this, the first step. And then the second step is where the piece that's going to fit down in here would slide on. Now notice on this one they cut that second step off. That's a mistake. We're going to have to fix that. Okay? But that's the whole concept here. The one lower panel fits on this, and the upper panel fits on this. And if this beam is too wide for the pit, then we've got issues. Notice here that after they cut it, they were able to shift the beam over and put bolts in here without having to slot these holes. It's only because they cut some of the beam off, and they cut more of it off on that side than they did over here on this side. So that meant that these holes, which there are 4 of, which don't make sense because there's only 2 in the center of this post, meant that they could line it up and push it that direction and get the bolt holes to line up. But they're really, these should be slots. This should be a slot across here so that you can move this horizontally. And as far as these ends, that I'm not too sure what to do about. So let's talk about this hole on this front post. Notice on this one that it's going to go into the steel that's on the edge of the pit. Probably not a good idea. If this hole were actually down here lower, then it would go into the cement. It'd probably be a better deal. There is a hole underneath that will go into the cement, but here you're going into steel and then into cement, and you're not very far below the surface of the cement. If the cement's fresh, it's just going to buckle and crumble up anyway. So it would be better if this hole were probably down lower on these beams. These beams are the same beams used on the other end on the dyno, and that's why this hole is where it's at, because it fits a hole that's already on the dyno. Okay, so when we lay in these front pieces, they're supported by this flat panel that's going to have to be anchored into the floor. And we supply 2 types of anchors. Okay, one, you just drive it down and put a bolt on the top, and if you use those kind, you'll have to cut the tops of these off because they'll be sticking up. They'd be tripping hazards. So if you use the other kind where you set the anchor into the ground and then put a bolt on the top, that's probably a better choice. But neither one of them will fit through the holes. So your only choice is a lot of extra work. You have to set everything up to where you're going to put your holes, mark it, then remove it, then drill your holes, put your bolts in, put everything back on top. If they just made these holes a little bit bigger around, so where we could fit these through the holes, we could drill with the plate in place and everything lined up. We wouldn't have to do twice the work. All right, in order to put an edge on this one so that we could put the rail on that, since we cut that short, we welded this piece on here. So the suggestion would be, rather than build these with those 2 steps on the end, build the cross rail short, build a plate that you just put on here and maybe bolt to it, so that it could slide. You know, you could put your bolts back in this area so they wouldn't be interfering with this, but that way this plate could slide in and out so that you could adjust right up against your wall as necessary, rather than have this beam built in such a way that the pit has to be absolutely perfect for it to fit in there. So this is how the beam is built with the 2 steps there. You can see the 2 steps. And those are welded on. Well, obviously from a manufacturing point of view that might be simple, but when you're trying to fit it into the pit, the pit has to be perfect. And most pits are not perfect. So the idea would be to make this piece and this piece part of a sliding piece that basically you bolt it on underneath, and you could adjust that as necessary. So you can see what we had to do over here on this one after we cut the beam short to fit it into the pit, and then we were able to just weld those pieces on in order to accommodate the sliders that go on the top. But there has to be a simpler way, rather than having this beam be a precise fit in a pit that isn't very precise. Okay, so we have the covers on the rear roll set. They're not tightened down. The plumber's finished putting in the sump pumps down here, and some sort of an alarm system if the pumps are not working, and a whole lot of extra cable tied in there. And then they plumbed it into this drain here on the side of the wall. The electricians finished the installation of the 240 volt AC power to my junction box over there, that box right there, and I've checked out the eddy current. The eddy current is functional, and the hydraulics are functional as well. Okay, the air hose down there and the line that goes to the front load cell, I've kind of got that all tied up so it's out of our way. It'll still probably drag the floor a little bit when it gets fully collapsed, but should be better than it was. We're about to put in all the front panels. We have the top covers on sort of loose. Once you get all the panels in, you're going to want to kind of move the unit forwards and backwards to kind of self-align everything. One of the critical things is to make sure these panels don't touch the rolls, so that when you get it all aligned, you don't have any kind of rubbing. So. Okay, so turns out once we got everything in here that the pit is too narrow. It's not wide enough, and the panels will not all fit. So the solution is going to be that we're going to have to probably trim an edge off of the outside-most panel, or one of the panels, not necessarily the one on the outside. We're going to have to trim one of the panels. We'll have to do it on the ones in the middle as well, because simply the pit is just too narrow by maybe an inch. Maybe not quite that much, maybe a ½ inch, but it's just too narrow. The problem with this installation is that the pit dimensions are so critical to getting this dyno in the pit. If the pit isn't made quite right, the dyno just doesn't fit. Square peg in a round hole. Okay, end of the second day. One of the issues that's now readily apparent is we've got some height issues. You can see this panel here and this panel here that I've put on. Obviously the lower panels are too high in the front and causing these to raise up in the rear. So some leveling issues that are going to have to be sorted out. Try to get things to slide like they're supposed to. I don't think that's as much of an issue in the front, although you can see we do have some gap on these, but not too critical. Now, the other thing that's very important is to understand that when these lower panels go together, there's a nylon strip in here, and that nylon strip serves two purposes. One is it is how the upper panels are going to glide across there. The other thing that it does is all of your lower panels have to be butted up against those nylon strips tightly. Then that produces the exact width that you need for the top panels to go through. So if there's any gap like there is on this one, those all have to be squeezed tight so that all of them fit, these lower panels fit tightly against that nylon strip down there. Then if you get them all that way, you should have enough gap to get all of your top panels in place. So down into the pit down here, we still have to anchor the trunnion bearing for the drive shaft, but we can't do that quite yet until we get the height thing sorted out. So we'll just leave that unanchored until the very end. That'll probably be one of the last things that they do. The other thing, these flat panels here that lay on the floor, they'll have to be anchored into the floor eventually. But again, that's one of the last things that we'll do, because we have to get all these sliding panels such that those, once they are all in place and these slide like they're supposed to, then we can anchor those panels to the ground. So I have the sensor box positioned. A little bit of the black cable left down here to where they could move it around, although there's not really enough room for the power cord, but I did buy them an extension cord. If they want to use it, they can, so that they can move that trolley either maybe towards the back or maybe towards the front. I don't know that they'd really need to move it towards the front much, but so that's giving them some movement, some freedom of movement with the trolley. As far as the Ethernet cable, I left it laying here. It's not tied in tightly. It is tied to this so that it's stress relieved and it's not going to be pulled if they pull it out. But that gives them freedom of movement with the trolley if they need to. So there's excess Ethernet cable there for that. The computer is set up and it's ready to go. Printer, I got it all set up. Computer, tried to tuck in all the cables behind the monitor as best I could. The router and the computer, and then I bought this power strip for them. There's also a connection here for one of the monitors that's outside, and we'll walk outside here. And what you should see is this monitor up here is going to be a copy of the Windyne screen inside the test cell. So they'll be able to see what's going on out here as well. And then the second monitor is going to be used for a camera system, I believe, so that they can have a camera on the dyno operator or perhaps the engine or whatever, and they'll be able to see it on that.